Hello and welcome everyone. Hello. Am I audible clearly? Hi Ramchandra. Hi Pawan Kumar. Please write down yes in the chat box if I'm clearly audible as well as visible. Okay, thank you Pawan Kumar. Okay, so this is going to be the last day of our code camp, and it was a very great uh, journey interacting with all of you, right? And I have seen many of you have already been like following from the day one, and it's a very good thing if you have been following from the day one. Hi Pranjal. Hi. Okay, so we'll be starting the session soon enough. As it is going to be the last session, we'll be having a lot of discussion with each other, and I'll be like answering all your queries if you have any kind of queries. Yes, I'm Gujarat. I'm from Gujarat. Okay, so we'll be like I want to keep this session very much interactive. I want everyone to like if you have any kind of doubts, you can post it right in the chat box. So basically, this session is going to be more like interactive session rather than just simply solving the questions and just discussing how to solve each and every question, right? So I'll be discussing, like say, just like the previous session, I'll be discussing two questions right now, and I'll be giving you one in the uh, homework to all of you. But आज last session join करके अच्छा लगा. I guess Pawan, you have been following from the day one, right? I'm starting from the first day, but college work से चार पांच सेशन अटेंड नहीं कर पाता नहीं कर पाया live. Yeah, मतलब it's very hard to maintain consistency. I also agree with you if you have been like working professional or like simultaneously going to colleges, right? Good, but then also then you have maintained the consistency. It's a good signature. Like you are willing to learn DSA, right? So I'll be sharing my screen and I'll be uh, starting the session. So first of all, before starting the session, I would like to know, do you guys have any kind of queries regarding any how to prepare for DSA, anything? I'll be more than happy to reply and have a good conversation with everyone. कोड काजे का वी इंटरव्यू का फॉर्म आया कहाँ से प्रिपरेशन करें इंटरव्यू के लिए ओके सो कोड काजे so what will be like what is the position education edu. Okay, so you can follow. Let's say if I can tell you about the interview part. Basically, if the interview is going to be around DSA, then what you can do, you can prepare interview centric questions, right? You can follow any kind of SD sheets, and do not jump here and there between different SD sheets, right? Keep on consistently following one SD sheet, and that will be more than enough. And simultaneously participate in weekly coding contest, daily problem of the day, and something like that. मयंक सोमानी ही से सर पूरे कोड कैंप की प्लेलिस्ट सर पूरे कोड कैंप की प्लेलिस्ट बनी हुई है हाँ द एंटायर प्लेलिस्ट ऑफ द कोड कैंप इज अवेलेबल ऑन द Geeks for Geeks YouTube channel. You can also like let's say if you are attending the session for the first time, you can start the code camp, or let's say you can start this streak starting from the day one. Watch the session on the first day, keep on practicing the homework questions, and you can follow the uh, like code camp at your own pace as well, right? So the entire playlist is available. Sir preparation कर रहे हैं लेकिन resume शॉर्टलिस्ट नहीं हो रहा हाउ कैन यू रिगार्डिंग दिस पॉइंट ओके सो इफ रेज्यूमे शॉर्टलिस्टिंग की दिक्कत आ रही है ना देन व्हाट यू शुड डू basically there is a possibility like let's say if you are applying for a backend developer role and inside your resume you haven't mentioned anything about backend technology or anything, right? Basically if you don't do such kind of thing, if you don't mention any of the keywords related to that specific profile, then your resume, it is possible that your resume not might not get shortlisted. Okay, so try to add keywords to your resume. And see, resume shortlisting, it takes lots of effort. You need to consistently keep on applying to, let's say, 5 to 7 companies each and every day. At least at the end of the week you will be getting call from 1 to 2 companies, right? That is how you hunt for a job. Okay. Vaishnavi, is this playlist enough to revise DSA, the day 21 days? Yes, you can use this playlist as a revision part as well, because each and every DSA topic, starting from basics to advanced, have been covered over here, and the standard problems as well as the interview centric problems have been covered. So you can take this entire playlist as a revision as well. Okay, sir. आज से ऐसा ही करेंगे. Okay, okay, Pawan. What are the good projects for data science role? Okay, so regarding data science role, I will not be able to answer very nicely. So regarding DS or anything or interview centric, I'll be more than uh, okay. So now let's start without any delay. I'll be discussing the question, and I'll be sharing the link as well. Okay, and in between the session, let's have a communication, right? So let's make this session interesting. Okay, I hope my screen is visible to everyone. Okay, so just a minute, let me open this stream as well. Okay, thank you, Pawan. Can't able to solve simple array questions. Don't worry, you need practice. You need to solve standard question first of all, and then you can solve the other questions. Okay, so the first question is equilibrium point. Okay, so before directly going to the question, I would like to explain you different, like let's say, a new topic to everyone, and the modification or the usage of that topic will be done in this question. Okay, so let's start. So the topic which I'll be discussing today is prefix sum array. Okay, have you heard about the word prefix? Can anyone from the audience write down what does it mean by prefix? Or let's say if I have given you a string, something like that, or let's say if I have given you an array, and now in this array, if I am saying that I want to, if I'm targeting this array containing 2 and 12, what does it mean? It means it is a prefix of this array, right? Similarly, inside this string, if I'm saying that this string ab, it is a prefix string for this string, right? And if I include only the alphabet a, then I can say it is called a prefix string. Basically, if you start including the elements starting from the zeroth index, then that means you are targeting the prefix of that array, or of that string. So now over here, let's say if I give you an array 1, 2, 3, 4, 5, and 6. So now what I'll be doing, I'll be creating, this is the input array given to you, and now based on this I'll be creating one more array, that is called the prefix array. So what does it mean, the prefix array? So what I'll be doing, basically I'll be creating a prefix sum array. Just give me a minute. Okay, so basically I'll be creating a prefix sum array of it. What does it mean, prefix sum? We have seen the word prefix, we need to know what is prefix sum. So basically in this array prefix, what I'll be doing, at each and every index I'll be storing the sum of all the elements starting from the 0th index till the ith index. Okay, currently my I is standing over here. So what does it mean? I need the sum of all the elements starting from the 0th index till the index number 0. Okay, so that means only one element will be included. Now I'll be taking my pointer I forward, it will be pointing to this index number 2. This is 0, 1, 2, 3, 4, and 5. Any doubt till now? Yes, exactly, Pratik. Yes, that was quick enough. So now currently I'm standing at the index number 1. I need the sum of all the elements starting from the 0th index till the ith index. So that means sum of this many elements. 1 plus 2 will give you 2. Now for this second number, index number 2, what I'll be doing, I need the sum starting from 0th index till the index number 2, that is 1 plus 2 plus 3, that will be equivalent to 6. Now for this, starting from 0th index till the index number 3, that is 1 plus 2 plus 3 plus 4. Or what I can do, I can add this sum, that is 1 plus 2 plus 3, it is present at this index, plus this element 4. 6 plus 4 will give you 10. Now for this index, I can add 10 and I can add 15. That will be giving you 15. And for the last index, I can add 15 and 6. That will give you 21. Basically, at each and every index inside the prefix sum array, the value present, let me write down the definition, what value will be present at each and every index. So basically, inside the prefix array, prefix of I, it is equal to the sum of the elements starting from the 0th index till the ith index in the input array. Okay, I can represent the value present at each and every ith index in this manner. Is it clear? The idea about prefix array, prefix sum array, is this clear to everyone? Yes or no in the chat box? A quick reply from everyone. This topic, this prefix sum array, will be used in many medium to hard kind of questions. Okay, so this topic is very much important to understand. A quick reply from everyone whether this was clear to you or not. Okay, thanks Pawan. Thanks for the confirmation. So now, similar to this, what do we have? We have something called as suffix sum array. What do you understand by suffix sum array? What does it mean by suffix sum array? Can anyone guess what do you understand by suffix sum? It will be something opposite of prefix sum, right? So now let's say I'm creating a suffix sum array. So what do you mean by suffix sum array? Reverse order of prefix sum. Okay, so reverse order, does it mean if I reverse this entire array 21, 15, 10, 6, 2, 1, and if I store this value, will it be the suffix sum? No, it won't be. So basically, this is reverse of the prefix sum. How is it reverse? Actually, its reverse means that it will be containing the sum of the element starting from the last index. Okay, so basically, let's say if this is the definition of our prefix sum, then suffix sum will say that suffix of I is equivalent to what? It is equivalent to the sum of the elements starting from the last index, and last index is n minus 1th index. It is n minus 1th index and till the ith index. So let's start from the last index. For the last index, how many elements are there from n minus 1th index to the till the current index? How many elements are there? Only one element, that is 6. Now for this, what will be the value? Sum of all the elements from last till current index. 5 plus 6 will give you 11. Now for this, what will be the sum? It will be 5 plus 6 plus 4, or you can say 11 plus 4. That will give you 15. Now for this one, it will be 5 plus 6 plus 4 plus 3, or you can say 15 plus 3. It will be equivalent to 18. And now for this one, that will be 18 plus 20. 18 plus 2 will be equivalent to 20. And for this one, this will be 21. Okay, it is not exactly reverse of this prefix array, but somewhat values will be similar. That is, the last element and the first element of prefix and suffix will be equivalent, because the last element of prefix denotes the sum of the entire array and the first element of suffix denotes the sum of the entire array. Yes, exactly, Pawan. Sum from the last. Was this part clear? Prefix sum and suffix sum. Is this part clear to everyone? Yes or no? Okay, thanks for the confirmation. Okay, so now let's move to this question and understand what this question say. Okay, so I'll be giving you 4 to 5 minutes to read out the problem statement. I'm sharing the link of this question in the chat box. Okay, so try to read down the problem statement and try to understand what does it mean. Okay, so read down the problem statement, go through the examples as well, and just write down yes in the chat box if you have gone through the question. Okay. This is also one of the like whatever we learned right now, prefix sum, suffix sum, something can be applied over here. Okay, that was a hint from my end. Have you gone through the problem statement? How many of you have read the problem statement? There are only two lines. I guess everyone has read. Yes or no? Quick response from everyone if they have, uh, if you have read the problem statement. Okay, thank you, Arushi, for the confirmation. And one more. Okay, so Pratik and Arushi have read. So let's start. So what does it mean? So the question says that first of all, the name of the question is equilibrium point, and the difficulty level states easy. Okay, and why is it easy? You will understand. See, if you haven't heard about prefix sum or suffix sum, then this question might be difficult for you because the expected time and space complexity requires the knowledge of prefix and suffix sum. Okay, so now over here in this question you will be given an array of positive integers. Okay, and the task is to find the first equilibrium point in an array. What does it mean by equilibrium point? So equilibrium point in an array is a position such that the elements before it is equal to the sum of the elements after it. Basically, if I say the index number, let's say 3 in some array is the equilibrium point, then the sum of the elements from 0 till 2 and some of the elements from 4 till n minus 1 will be equal. That is what the question is trying to say. Problem statement is clear, try to solve. Okay. Sir, if and I, what? Education need you. Okay, so now let's try to just quickly go through this example. Okay, so here is our example. Inside this example, we have an array that contains elements 1, 3, 5, 2, and 2. Okay, so now I want to find the equilibrium point. Equilibrium point means, let's say if I'm saying that this index, this point is the equilibrium point, then what else I need? I need the sum of the element on the left hand side. 3 plus 1 will give you 4, and the sum of the elements on the right hand side. 2 plus 2 will give you 4. So exactly, yes, I can say this is an equilibrium point because you can see left sum and right sum are equal, right? So now what about the other point? Let's try to see the other points. Let's say if I'm saying that this point is an equilibrium point, what does it mean? So it means the sum on the left hand side is equal to 1, on the right hand side it is equivalent to 9. Are they equal? Is 1 equivalent to 9? No, it is not equivalent. So 3, this position is not the equilibrium point. So basically in the question, what you have to do, you have to find the first equilibrium point in an array. So for this input, the output comes out to be index number. Okay, so indexing, according to the array, the indexing will be one based indexing. For this question, the indexing will be one based indexing. It is mentioned over here as a note that written the index of equilibrium point, one based indexing. So what will be the index? 1, 2, 3, 4, and 5. Hence, the output 3 will be printed. Is the question understanding clear to you? Hi, Sanskar. Hi. Sir, if number of elements in array is odd, then how we will add before and after? See, now I guess this part was clear to you. Education edu, was this clear to you? Is it clear? Yes or no? Education edu, is it clear? Your doubt? So now try to think as I've explained the problem statement. Now I expect, after understanding prefix sum, suffix sum, now I expect from you guys what can be the solution, right? Can anyone say the brute force solution? Let's directly go through the brute force quickly, and till then you can think about how you can utilize prefix sum and suffix sum array. Okay, that was the hint from my end. Rest of the people who already have understood the brute force, who have not understood the brute force, focus over here. Okay, so what will be the brute force approach? A brute force approach is pretty simple. What I'll be doing, I'll be having one of the iteration over the entire array, starting from this index. Now at each and every index, I'll be running a loop on the left hand side, starting from I minus 1th index till the 0th index. And I'll be running the loop on the right hand side, starting from I plus 1th index till the last index, that is n minus 1th index. So running a loop on the left hand side of this one will be having sum 0. And now running a loop on this right hand side, that will be 3 plus 5, 8, plus 2, 10, plus 2, 12, right? So I got the left sum and right sum. Now compare there. Do you see 0 equivalent to 12? No, it is not equivalent, right? So the index 1 is not our equilibrium point. So let's see the other part, this position. So left sum, run a loop from 1 to the index number 1. So one element will be there. Run a loop from 3 to last index. 5 plus 2 plus 2, that will be equivalent to 9. Sum will be, this is not equal, right? 1 is not equivalent to 9. So basically this approach can be applied as a brute force approach, in which the outer for loop will run on the total number of elements, and there will be two inner for loop which will be running for the left sum and the right sum. And the overall time complexity for that approach comes out to be order of n square. That was the basic brute force approach, and the space complexity will be constant because we don't need any kind of extra space to store the sum or anything, right? So what about the hint I gave you? Pratik says for brute force, for every position, add sum on the left and right. Exactly, Pratik. Yes. So, what do you think? What can be the utilization of this prefix and suffix sum? So now let's understand. What if I have the prefix array? What if I have the prefix array and the suffix array for the given array? Let's find the prefix and suffix array. Okay, so prefix array 1, 1 plus 3 will be 4, 4 plus 5, 9, 9 plus 2, 11, 11 plus 2, 30. And what about this suffix array? Starting from the last index, that will be 2, 2 plus 2, 4, and 4 plus 5, 9, 5 plus 9 plus 3 will be equivalent to 12, and 12 plus 2 will be 13. I have suffix and prefix array. Okay, so we got an answer. Pratik says find prefix and suffix sum, and for every, check if they're equal. For every position, check if they are equal. Okay, so let's understand. Now I have the prefix sum and the suffix sum. Now I'll be iterating over this entire array, prefix or suffix, simultaneously, both of them. Okay. Now let's say currently I'm standing at this point. I am saying that this point is equilibrium point. How can I argue that? So basically I need the sum on this left hand side, and I need the sum on the right hand side. So what will be some of the elements in the input array? In the input array, I need this sum actually, right? And this sum is present at the index number 2 inside your suffix array. So I'll be fetching this value. So let me just change the color. So I'll be getting this value, and now I need the sum of all the elements. This is my current position. I need this sum, that is from index number 1 to the index 1 minus 1 minus 1. That will be from 1 to 0. This is not possible, so the sum on the left hand side will be equivalent to 0. So I got two sum. Left sum is this, and right sum is equivalent to 12. This is not equal, right? So this is not the equilibrium point. So basically I have tried, like basically we have eliminated the loop which we were using to find the left and the right sum. So now moving on forward with the index number 2. Index number 2, I am saying that this index is equilibrium point. I need this sum. This sum is present at this index, at the index 3 in the suffix array, and this entire sum is present at this at index 1 in the prefix array. So is 1 equivalent to 9? No, it is not equal. So this point or this position is also not an equilibrium position. So moving on forward, at this index number 3, let's see if this is equilibrium point. I need this sum. This sum is present at which index? At index 4 inside your suffix array, and this sum is present at which index? Index number 2 inside your suffix array. So this is what we are going to compare. So is 4 equivalent to 4? Yes or no in the chat box? Yes, obviously a very easy question, right? Is it possible with 2 pointers? Can we solve with 2 pointers approach? See, 2 pointers approach is required to look for an element. What kind of element? That adds up to some kind of sum or something, right? So 2 pointers approach will not iterate over each and every left and right sum for each and every index, but over here you will be able to do so. Basically you need to test each and every index, and 2 pointer approach is optimization, and it requires no iteration or repeated iteration, right? So that's the reason you cannot use 2 pointers approach, because we over here we are not looking for any key element or any double elements, right? We are not looking for any pair of elements. Is this clear to you everyone? Yes or no? Who are here after day 1? I am here after day 1. Okay, so So let's start again. Okay, so is this part clear to you? Yes or no? A quick reply from everyone is if this part is clear to you. Clear. From Pawan Kumar, Pawan Kumar says clear. What about Pratik, Arushi, Education EDU? Is this clear? Okay, Pratik, it's clear from Pratik as well. Okay, thank you for the confirmation. Now we know how to generate prefix array. Okay, so let me show you how to create prefix array. Okay, so let's say I have created an empty array that goes by the name prefix, and its size is equivalent to n, and all the elements are equivalent to 0. So now I'll be running a loop on the index number 1, starting from index number 1 to index lesser than the last one. Okay, and now prefix of I is equivalent to what? Prefix of I is equivalent to the element plus what? Prefix of I minus 1. Prefix of I minus 1. This is how you generate an entire prefix array. And what about the suffix array? And one more initialization step is required, because for the prefix of 0, we know that the element is going to be equivalent to the element at the index number 0. So the initialization step is going to be this. The prefix of 0 is going to be array of 0. Now what about the suffix array? Suffix of n. Similar to prefix of n, what I can do, I can write down suffix array starts from the last index. So last index will be initialized n minus 1 is equivalent to array of n minus 1. And now I'll be iterating from which index? From the second last index, n minus 2 to I is greater than or equal to 0. Is it clear? Yes or no? So now suffix of I is equivalent to what? It is equivalent to array of I plus suffix of I plus 1. Right? This is what the suffix of I denotes. Isn't it similar to prefix array, right? We simply need to have a clear understanding about prefix or suffix. So this is how I will be generating prefix and suffix. And how will I compare each and every point, right? I need to see whether it is an equilibrium point or not. Okay. So what I'll be doing, I will be running a loop on the, so let me write down the steps of the algorithm. Okay. We will optimize this algorithm as well. Okay. So the first step is to generate prefix and suffix array, right? So after generating the prefix and suffix array, what else I need? I need to iterate over the input array. I is equal to 0 to I is lesser than n. And after this, what I need to do? I need to check what? That ith element or ith position is my equilibrium point or not. How can I do that? I need the sum of the element from 0th index till I minus 1th index, and I need the sum of the elements from I plus 1th index till the last index. So this sum will be available at I plus 1th index inside your suffix array, and this sum will be available at prefix of I minus 1. I'm stretching a lot on this question because over here this question a very important topic, that is prefix sum suffix sum, is being discussed. That is the reason I'm extending or stretching out more on the algorithmic part of this question. Okay, till now, is it making any sense to you guys? Is it making sense what we are doing over here? Yes or no in the chat box if this makes sense to everyone. Okay, thank you for the confirmation. Now I will be iterating over each and every array element, right? Starting from 0th index till the last index. Now, there is one catch, right? We know that I cannot find I minus 1 when I is equal to 0, and I cannot find I plus 1 when I is equivalent to n minus 1. For the last index, I cannot find I plus 1, and for the first index, I cannot find I minus 1. So you can handle this part separately, or you can put two if and else condition like this. If I is equal to 0, then you have to check. What you have to check? You have to check and so now if I is equivalent to 0, first of all, let me have two different variables, left sum and right sum. So left sum will be equivalent to 0 and right sum will also be equivalent to 0. Now, if I is equivalent to 0, then I will be having no left sum. If for I is equal to 0, no left sum is present. So I'll be adding one more condition. If the right sum or the prefix sum, what I'll be doing, suffix of I plus 1, if this suffix of I plus 1 is equivalent to 0 or not. Basically, I'm saying that left sum is 0. Now, what about the right sum? It will be present at the index I plus 1. I'll be finding its sum. I'll be calling it as right sum. Is this equal to 0? Yes or no? No, it is not equivalent. Then, let's say if it is equivalent, then you will be returning the index. Returning the index, basically I plus 1 will be returned. Else if what? Else if, let's say I is equivalent to n minus 1th index, last index. So in that case, I know that suffix of I plus 1 is not possible for this. So what I'll be doing, I'll be checking if prefix of I minus 1, because left sum exists, right? It exists at the index I minus 1. If this is equivalent to 0 or not, then return I plus 1. One based indexing, that is the reason I'm returning I plus 1. Else what? Else you have to check whether you can add else if prefix of I minus 1. I already have explained this part, so not explaining it again and again. And suffix of I plus 1. If this is equal, then return I plus 1 directly. Return I plus 1. And here is the end of our for loop. So this is the entire algorithm to solve with the help of prefix and suffix array. Any doubt till now? Pratik says, can you list problems that require prefix sum after solving this? I would suggest that go to the, you can search for prefix sum and then write the keyword geeks for geeks. You'll be having a page that says prefix sum, details about introduction to prefix sum, and some standard questions. Okay, so focus on standard questions. See, directly, no, there are no questions which will be using prefix and suffix sum. This is very few questions are there, right? So basically, they will be utilized, they will be used in a medium to hard level of questions. Okay, and whenever any kind of question requires you to answer queries in constant amount of time, and in such kind of questions where you require to have some, in such kind of questions, prefix and suffix can be used. So now, based on this, what will be the time and space complexity? What do you think? What will be the time and space? The algorithm is in front of you, so read the algorithm and guess the time and space complexity. Order of n for both. Pratik says order of n, Pawan says order of n. And what about the other people? What do you think? What will be the time and space? Space order of n plus n. Yes, exactly. To be more precise, space will be order of n plus n. That is two arrays, prefix and suffix array, which are having size equivalent to input arrays used. Arushi says order of n. Yes. And here is a for loop, a clearly visible for loop that is going to iterate over each and every array element. That is going to take order of n time. And for generating the prefix array, order of n. For generating suffix array, order of n. That is time complexity can be written as order of 3n, and space complexity can be written as order of 2n. Basically, linear time and space complexity for this approach. Now I want to, let's say I want to decrease the space complexity. I don't want to create or generate prefix and suffix array. Can I do without generating prefix and suffix array? Try to think what actually we are doing over here. Is it always required to have a suffix array? Do you guys think that suffix array is required each and every time? Yes or no? What do you think? So let's observe something over here. So over here, no. So Pawan says no. And also do mention the reason that why don't we need suffix array. Okay. So let's say I'm doing one thing. What I'm doing, instead of this suffix array, I will be having a sum variable that says the sum of the entire array. The sum variable denotes the sum of the entire array. So somehow, let me show you in this part, in this test case. Zero, 1, 2, 3, and 4. Now over here, if I want to find the suffix sum, let's say currently I'm standing at this index. So what I'll be doing, I'll be having two different values. That is sum variable that will be initially equivalent to the sum of the entire array. And let's say what is the sum? It is equivalent to 13, I guess. 5 plus 3, 8, 9, 10, 11, 12, and 13. Its sum is equivalent to 13. Along with this, I'll be having one more variable, that is prefix sum. This are variables, they are not an, it is not an array. Prefix sum is initially equivalent to 0. So now this sum variable will be helping me to find out the suffix sum, and this prefix sum will be helping me to find out the suffix sum. So let's observe how can we achieve it. Currently I'm standing at the index number 0. So now for this index, what I need the suffix sum, I need this sum. So the first step is to whatever element you are encountering for the first time, subtract that element, subtract that element from the sum. So that will be 13 minus 1 will be equivalent to 12. So this 12 which you have got after subtracting the current element is the sum of this part. It is the right sum. So after subtracting, what else do you need? You need to compare the prefix sum and the sum. Do you see sum and prefix sum have the same value? No, it is not having the same value. So moving on forward. Now, before moving on to the next element, make sure you will be adding this element to your prefix sum. So 1 will be added. So prefix sum will be 0 plus 1, that will be equivalent to 1. Now moving on forward with this. Now next element. So on encountering a new element, as I have mentioned, you have to subtract that element from the sum. So 12 minus 3 will be equivalent to what? 9, right? And what else you have to do? So first of all, the first step is to subtract the current element. This is the first step. This is the second step. Second step is to compare the value of sum and prefix sum. And the third step, that is after, before moving to the next position, what else do you need? You need to check. What else you need? What else do you need? You need to add the variable to your prefix sum. Add the variable to your prefix sum. This is very much easy to understand. Now I have encountered, now I cannot see 9 and 1 equivalent, so I need to move forward. So I'll be adding the element to my prefix sum. So 1 plus 3 will give me 4. Moving on forward, this element. So now first encounter, so 9 minus 5 will give you 4. And what else? Now I need to compare this step. 4 is equivalent to 4. Yes, exactly. So this is my equilibrium point. I think we can, okay, so Pawan says I think we can calculate when I'm iterating the array. Okay, I missed so many chat. Okay, so Pratik says subtracting from total will give the suffix value at any position. Okay, yes, exactly, Pratik. Maybe no. Not Milan says no, and Pawan says I think we can calculate my iterating and then check if okay. So basically, we simply can do this and achieve this with the help of variables as well. Okay, so if you focus, if you like pay attention to actually what is happening in your algorithm, no, you will be able to observe that something is redundant. This data is not at all valuable in order to solve the current sub problem. So you can get rid of those data, extra data. See, in the prefix and suffix, some extra things were stored, right? Like if I was working on this element, why I don't need any kind of this data. This data is redundant, right? So we can avoid storing the extra data which we are not going to utilize anywhere in the question. Okay, so over here we don't need any kind of prefix sum, suffix sum, but the knowledge of prefix and suffix sum has helped us a lot to finally reach to a very efficient solution, right? So that is the reason I was paying more, like let's say, I was stretching out the topic of prefix and suffix sum. I guess you have understood the reason. Okay, so this way optimization and everything can be like, you'll be getting an idea in this manner if you know actually what prefix and suffix sum is. Okay, so directly in the interview as well, they will not ask many questions having prefix suffix, but let's say indirectly they will be using for optimization part. Okay, so these are the steps. Now before this, what else do we need? I need the sum variable. Sum variable will be equivalent to what? It will be equivalent to 0 till the last element, that is n minus 1 array of I. Okay, I'm writing down the mathematical representation using sigma. You can imagine this with the help of a for loop, right? Everyone is smart enough over here. Right, so sum is equivalent to this. Now what else do we need? I need one more variable, that is prefix sum. And initially this value, this variable is going to be storing 0. Prefix sum is equivalent to 0. Right, this is the initial thing I need to do. And now this part can be included inside your for loop. So I'll be having a for loop starting from the index number 0 to I is lesser than n, last index. So the first step is to get rid of the current element from the entire sum. So I'll be getting suffix sum, and luckily if I'm able to find any of the index that says sum is equivalent to prefix sum, just directly return the value of that index. Return I plus 1. Okay, is this making sense? This is the efficient algorithm. Is it making sense, yes or no? Any doubt? Anyone? Okay, so this is going to be our algorithm. So let's directly code this part. I guess this implementation can be done in any other languages. I have written down the algorithm and we can do it. But what about the variable data types? So keep in mind that we need to use what kind of data types. See, in this kind of questions, which seems to be very much easier, just it is for being on the safer side, just pay attention to the constraints. Okay, every time pay attention to the constraints. It is possible that you might encounter some memory overflow for some variables, and that might lead to a wrong answer. Sir, I have good experience. What mathematics needs for better? Okay, so someone says I have good experience. What mathematics needs for better? I didn't get you. Can you be more elaborative or rephrase? Okay, so I was saying about what kind of data type I need. Let's say I am creating a sum variable. Okay, and I have a prefix sum variable that is initially equivalent to 0. Now sum variable is going to store the sum of the entire array. So at max, in the worst case, what can be the value that will be stored inside my sum? Let's say I take a worst case example in which the array size is 10 to the power 6 and the array elements are 10 to the power 8, each and every element. Now, what will be the sum of that entire array? That will be 10 to the power 6 into 10 to the power 8, 10 to the power 8, right? That will be equivalent to 6, 12, 14. 10 to the power 14 will be the sum of that array in worst case, and 10 to the power 14 cannot be stored in integer, right? So you need the sum variable to have long data type. And what about the prefix sum? Let's be on the safer side and have prefix sum also with long data type. So now let's start the iteration. I is equal to 0 till I is lesser than n and I plus plus. So the first step was to get rid of the current element from your sum. But before that, I need the sum of the array element, all the array elements, I is lesser than n. And sum plus is equal to array of I. I'll be getting rid of the first element, array of I will be removed from the sum. So this is my suffix sum now. And if sum is equivalent to prefix sum, and directly return I plus 1 because that is your equilibrium point. If this is not the case, then what? This is not the case. You first of all need to add the current element to your prefix sum. So array of I will be added. And at the end, just directly return the value of what it is mentioned over here. Your task is to return -1 if no such point exists. So this for loop will be executed, and if nothing is returned, then you need to return -1. I have good experience in JavaScript. What mathematics needed for DSA? Basically, like, are you saying that what mathematics do you need for DSA? Is this your question? Just write down yes if this is your question. Okay, so compilation is successfully completed, and let's try to submit it. And we can see the problem has been successfully solved, right? See, I got a question from Nagarjuna. So he's saying that I have good experience in JavaScript. What mathematics is needed for DSA? I guess this is what you are asking, right? So see, mathematics is not much needed for DSA. If you are looking for going into competitive programming, then it is required. Very much mathematics will be included. You will be reading out about, let's say, different algorithms that will be directly the question in competitive programming can be directly from your mathematics, right? So for DSA, a very little of DSA is required, just like pseudo-Faraday and prime numbers, GCD, such kind of mathematics. A very small portion of maths is included for the DSA part. I hope I was able to answer your question. Okay, so now I want to announce something. I want to share something with you guys. Okay, it will be very much interesting for you. As I can see, the audience are very much active nowadays, so I think I should share this right now. So currently there is something going on at Geeks for Geeks. So it will be starting from 1st of July, and that goes by the name Geek Olympics. Okay, so what will be this festival? This is kind of festival at Geeks for Geeks in which coders like you can participate in different events, right? So you can register over here, and it will be starting from 1st of July, and it will be extending till 31st of July, an entire month of this Olympics. So what do you get? There are different events possible. So there is something called as Code Extreme. So basically, if you explore, there will be POTD, GFG weekly, and you can go through this part what actually this event contains. And the interesting part, which you might be much like, let's say, you can attend these sessions. The interesting part is that there are some live sessions available. So basically, there will be live daily like study sessions, 31 days, 31 sessions, a free opportunity for you to upskill, master new technology. And basically, industry experts will be called on the session, and they will be uh, giving you the reality. They will be sharing you the actual thing about what industry is looking for in the employees. They'll, let's say XYZ technology, like let's say Java backend development, right? We want to know from the actual industry experts who have been working from years and years, right? And who have been working in a good product based company. So they will be in the interview, and you will be able to post your questions, and they will be sharing the knowledge, and they will be sharing you the path. So this is the most interesting part. You can check the other interesting things, other interesting events as well. Okay, I'm leaving this part of exploration on you guys, and there are some prizes also available, right? So you can explore this page, go through this page, and also register it over here. I'm already registered. Okay, so Pawan Kumar is quick enough. He has already registered. Good. Okay, I'm sharing the link of it in the chat box as well. It might help you. And yeah, I've shared the link in the chat box. So now let's get back. So was the question clear? Anything, any doubt from anyone regarding this question? Equilibrium point. Else we'll be moving to the next question. Uh, Someone says, when I am registered here, after what I have to do here, sir? Can you tell here? So after registering over here, you will be like able to see different events. You'll be having the details. Let's see what else do we get. Let's say, okay, so I have registered. So after registration, you will be getting notified on the email as well. You can visit this page, right? So event has not yet started. On 1st of July, attend this and you will be able to see what all details are provided over here. Okay, explore the event and let's click explore the event. See, the details are already given over here. This is about the problem of the day. Now, Geeks for Geeks GFG Weekly. Let's explore. You'll be getting the weekly coding contest. Let's say God of Problems. Let's explore. This is going to be God of Problems over here. And let's see the other part, live stage. So this will be available. The sessions will be available on YouTube regarding this. So try to explore. Let's not spend much time over here. See, get hired, job arena. You can visit this and you can see the upcoming job posting over here. Okay, I hope this makes it clear. So now let's get back to, okay, what the future demand in software developer. Okay, so I will definitely attend this session. Okay, Pawan Kumar, most welcome. So the sessions will be starting from tomorrow itself, and I would like everyone who are attending this code camp daily, and I want you guys to visit the I want you guys in this session. Okay, basically I'll be hosting one of the session on Sunday. That will be on backend development. If you guys are interested about backend development and you want to hear from the industry expert what actually is going on in industry in the backend development and what to follow, and much more interesting things will be discussed, right? Okay, so I got one more. In Python we have a collection data types like list, tuple, set, dictionary. Is it necessary to learn DS like linked list, stack, queue? Yes, exactly. See, in Python, everything is like abstract. You don't know the internal working. This functionality is kind of a good part of Python, and it is also a bad part of Python. Because if you directly start learning Python, and if you don't have any idea how internally this data structures work, then you will not be able to understand or implement it. And interviewers want you in-depth understanding of this data structure. They don't directly want you to use the inbuilt functions and apply inbuilt methods, right? Okay, so I see many of you are interested, so do visit. You'll be able like post your every doubts and every query over there, and get the things replied from the mentor. Okay, so let's start. Let's again get back to the question part. Okay, so the next is a very interesting problem and a very famous question of arrays. Okay, so I'll be explaining this part, this cadence algorithm in a very interesting way, so that I will be able to guarantee you that in future you will not able to forget, like you will not able to forget this cadence algorithm. Okay, so I'll be sharing the link of this in the chat box. Node या Java या Python framework for backend. Okay, so according to me, I would go for Java. Java backend development is very much famous in the industry. Okay, I'm also interested in backend development. Which tech used in backend? Okay, so you can come to the session that will be for Java backend development. And in industry, Java is very much famous for backend development. And other technologies are also famous. I'm not saying they are the list common one. I've shared the link of the question in the chat box. Start reading the problem statement. I hope I was able to answer your question, Pawan Kumar. My favorite algo, sir. G. Okay. So we got okay. So Cadane's algorithm is favorite for Pawan. Good. Okay. So start reading the problem statement. A very small statement is there in the question. Okay. So let's start. So Cadane's algorithm, the difficulty level given to us is medium. Basically, if you don't know the algorithm, then obviously this is going to be difficult for you. If you already know, then you will be saying, okay, so this difficulty level does not justify the question, right? So given an array of n integers, find the contiguous subarray containing at least one number which has the maximum sum and return its sum. Okay, and this is the example. Let's go to the constraint. Array can be as large as 10 to the power 6. So nested for loop will not work. Obviously 10 to the power 6 into 10 to the power 6 will be 10 to the power 12. That many iterations not allowable, right? And the array can be as large as 10 to the power 7 and minus 10 to the power 7 as small as minus 10 to the power 7. I'm go from node and something used in Java. Okay, that's great. You can follow that as well, Pawan Kumar. Okay, so now first of all, before directly understanding about the question, I want you to explain subarray. Is everyone aware about this word subarray? What does it mean by subarray? Because this has been very much confusing for lots of you. Okay. So subarray is a contiguous part of an array with no elements or no nothing has been. So now over here inside this subarray, let's say if this was the array given to us. In this array, if I'm saying that this is a sub array 5, 10, and 9. I extract the elements 5, 10, and 9. This is a sub array. If I say 10, 9, and 10, 9, 3, this is a sub array. If I say 1, 5, 10, and 9, it is a sub array. If I say 5, it is a sub array. If I say 9, it is a sub array. What if I say 1? Let's say, what if I say 1 and 10? It is not a sub array, it is a subsequence. What if I say 1 and 5 and 3? This is not a subarray, it is a subsequence. Not a subarray, it is a subsequence. I hope every everyone it's clear what is a subarray and what is not a subarray. Basically, we need to know what is a subarray and what is not a subarray. A contiguous part of an array. Okay. So now I have to find out contiguous subarray which has the maximum sum, and inside the contiguous subarray at least one element needs to be included. And over here the array will contain positive as well as negative elements, right? Obviously if there are only positive elements, no, then obviously just directly return the sum of the entire array. Got it? Are you getting my point? If there are no negative elements, then there is no need of doing anything. Just directly return the sum of the entire array, and that is the maximum sum, right? Contiguous subarray which has the maximum, but there are negative elements present over here. So how will we solve this? Let's see the example number 1. It says 1, 2, 3 minus 2 and 5. So that says 1, 2, 3 minus 2, 1 and 5. 1, 2, 3, 1, 2, 3 minus 2 and 5. Okay, minus 2 and 5. So n is equivalent to 5, and for this I have to find out which subarray has maximum sum. So one of the approach can be I can find out all the subarrays 1, 1, 2, 1, 2, 3, 1, 2, 3, and minus 2, and the other one is 1, 2, 3, minus 2 and 5. This can be the subarray starting with index 1, that is the first index. Now I am writing down the list of the subarray starting with the index number, starting from the index or the element number 2. These are the subarrays. And now all the subarrays starting with element 3, all the subarrays starting with element number minus 2, all the subarrays starting with the element 5. I have listed down all the subarrays. So this will be having some 1, 3, 6. Let me change the color. This has some 1, 3, 6, and this will be having 4 as the sum. This will be having 4 plus 5, 9 as the sum. This will be having 2, 5, and 3, and this will be having 8. This will be having 3 minus 2, 1, 3 minus 2, 1, 5, 6, minus 2, and 5 minus 2, 3, and this is having some 5. Now, what is the maximum from all of this? I can see 9, hence the output for this comes out to be 9. Let's see. And output comes out to be 9, and the subarray contains the entire array 1, 2, 3, minus 2, and 5. Yes, exactly what we got right now. Is the question understanding clear to everyone what actually we have to do? A quick response from everyone if this part is clear, yes or no in the chat box. Okay, confirmation from Milan. What about Pratik? What about everyone else? Pawan Kumar. Pawan Kumar already has learned, right? Arushi confirmed. Pratik confirmed. Okay. So now what I want the reply from you guys, what can be the brute force approach? I guess the brute force approach is in front of you, isn't it? In the brute force approach, what you can do, you can find out each and every subarray, and for each and every subarray, get the sum of that subarray. Keep a global answer variable. Keep on comparing the sum with your answer variable. One initially answer variable will have minus infinite, right? One minus infinite, which is greater one, and the other one I got will be 3, which is greater. 3 is greater. 3 and 6, which is greater. 6 is greater. So 3, 6 and 4, which one is larger? 6 is larger, so answer remains 6 as it is. And 6 and 9, which one is the larger one? 9. So 9 is present over here. So in this manner, I can find out the maximum subarray sum. This is going to be my brute force approach, right? So what will be the, like, let's say this time complexity will be very much like it will be somewhat around n square. I can take it as n square. For each and every element, you'll be going through. It will be basically quadratic time complexity will be uh, reached by the brute force approach. Okay, so now I want to do something better than this. I want something better than this. So what I will be doing, see over here, these are different sets. Just give me a minute. Let me reopen this OneNote again. So now what over here, if you observe, I have written down the subarrays in sets, right? So this subarray set contains all the elements starting with the first index. This subarray set contains all the elements starting with the index number 1, 2, 3, and 4. This is a set containing all the subarrays starting with the index number 2. This set contains all the elements starting with the index number 3, and this is for the last one, fourth index. So what I can do, actually, instead of starting from the first element, I will be keeping track of the maximum subarray sum ending at the ith index. So basically what I'm trying to say, if I'm saying that I want to find maximum subarray sum ending at the index number 0, so how will I get? I'm saying that maximum subarray sum ending at the index 0. That means the last element is compulsory. You have to include the current element inside your subarray. Including the current element inside your subarray, what is the maximum sum among all the subarrays? So for that, I can get the answer as 1, because only one element is required. Now, what is the maximum subarray sum ending at the index number 1? That means last element will be the part of your subarray. So what are subarrays ending at index number 2? At index number 2, two element itself is ending, and the subarray 1 2 is ending. So what is its sum? Its sum is 3. What is its sum? Its sum is 2. So this will be which is maximum 1, 3 and 2. The maximum 1 is equivalent to 3. So now over here, for this element, I'll be doing the same thing, maximum subarray sum ending at this index, at the last index. So for this one, the element, the subarrays ending at the index number 2 are 3. You can include 2, 3. You can include 1, 2 and 3. Okay. So I've included 1, 2, 3. It will be having sum 6, 5 and 3. What is maximum? So the maximum is 6. So now I have understood what is maximum subarray sum and ending at the ith index. Now how quickly can I find this value? How quickly can I find this value? Was the part, was it clear to you regarding maximum subarray sum ending at the ith index? Is it clear for all of you? Is this part clear? What is this value 1, 3 and 6? Is it clear? Okay. Keep the sum as we move along the array. Change maximum if required in case we reach negative or 0. Start sum for that position and move forward. Yes, that can be one of the cadence algorithm, but I'm explaining it in a different manner. You are exactly clear. You are exactly correct, Pratik. So I will be finding maximum subarray sum ending at the ith index. So now I was talking about this index. Now I want to find maximum subarray sum ending at this index. At the index number 3. How many subarrays are ending at this index? So subarray minus 2, subarray 3 and minus 2, subarray 2, 3 and minus 2, subarray 1, 2, 3 and minus 2. This many subarrays are there, right? So I don't need each and every subarray. See, if I'm going to find all the subarrays ending at the ith index, then what is the difference between the brute force approach and my current approach? There is no difference, no, right? So basically, actually, I need maximum sum, right? I need maximum sum from all these subarrays. So what I can do, see, for this index number 2, I have got the maximum subarray sum ending at the index number 2 as 6. And now I am finding the maximum subarray sum ending at the index number 3. So what I can do, in order to find directly the value, in this I'll be utilizing the value 6. So the value 6 says that starting from the index number 0 till index I minus 1, the maximum subarray sum, whichever subarray you are including that is ending at I minus 1th index, has sum 6. Now I want to find what is the maximum subarray sum ending at the ith index. So what I can do, either I can add 6 plus array of I, that means this subarray, I need to compare the value of this subarray, or I have to simply compare the value of the single element in itself. These two values needs to be compared. Only these two values are required. These values are not required because previously I have got, for the index number 2, I already have maximum subarray sum ending at the index number 2, and that value was 6. My task is to find maximum sum. So for index I minus 1, I have answer as 6. Now for index I, if I want the answer, I'll be adding the element array of ith element to 6, or I'll be considering array of I in itself, because these two subarrays are not being uh, concluded, are not being included. All this will not give you any kind of maximum answer, then we have excluded it in this manner. Okay. ओके सो पवन, आर यू लिविंग? ओके सो सॉरी, आज की क्लास में यहीं तक कंटिन्यू कर पाऊंगा। कॉलेज की प्रेजेंटेशन बनाने को है भी कंप्लीट करनी है आज, कल सबमिट एंड डिलीवर्ड भी करना है। ओके ओके पवन, नो इशू। सो डू वॉच द रिकॉर्डिंग्स एंड आई गेस यू हैव ऑलरेडी learned cadence algorithm, right? So you can, yeah, but do come back again to watch what was the question I have given you in the homework. Okay, you can continue your work. Okay, so for the rest of the people, is this part clear? Arey, you are also acha. Everyone is saying bye. Okay, bye bye. Everyone say bye to Pawan. Okay, so I was saying that, is this part clear regarding this? Is this part clear, that how to find maximum subarray sum ending at the ith index? I will utilize the value which I have already calculated for I minus 1th index. Okay, I'll utilize the value which I have already created. I have already calculated for the previous index. So now, for each and every index, if I want to find the uh, so what I'll be doing in order to calculate this value, first of all, I will be finding out what is the maximum subarray sum ending at ith index for each and every position. Okay, so let's start. So I'll create one more array, and that array will be utilized to get the idea about the sum of the maximum sum subarray ending at the ith index. Okay, so 0th index, 1th index, 2th index, 3 and 4. So for the first one, if I want to find the answer, basically I will be adding, let's say I call this array as, let's say, what do you want me to call this array as? Let's say sum array. Okay, and for any of the position, for any of the position, sum of I is equivalent to what? Sum of I is equivalent to a maximum of sum of I minus 1 plus the current element, because only two sub arrays will not be included. That is the reason I am calculating these two values, or the current element as a sub array itself. So this is what I'm going to store at each and every index, and along with this I will be having an answer variable which will be initially equivalent to minus infinite. So now let's begin. Let's start. So starting from the first position. So for the first position, we know that nothing is present on its left hand side. Sum of I minus 1 is not possible. So what I'll be doing for the first index, I'll be putting 1 as it is. I'll be putting 1 as it is. Now I have got one of the answer, right? That is maximum subarray sum ending at the 0th index, that is 1. Compare it with the answer variable, which is larger, obviously 1. So answer updated to 1. Moving on forward, next. What is next? Next is index number, this one. So I want to find maximum subarray sum ending at index 1. So that is sum of I minus 1, that is 1, plus current element 2, and comparison with the elements value itself. That will be comparison between 3 and 2. What is maximum? I can see 3. So sum over here I'll be storing 3. So compare with answer and 3. 3 is obviously greater. Update the answer variable. Moving on forward, for this one, for this element. For this element, I want to find, so I'll be getting sum of I minus 1 is equivalent to 3. 3 plus current element is 3, and current element maximum of this 2 will be equivalent to 6 comma 3 and is equivalent to 6. So at this position, I'll be storing 6. Answer and 6, which is larger? 6 is large. Update the answer. Moving on forward with the next index, index number 3. For the index number 3, I will be doing the same thing, and that same thing is a maximum of sum of 6 plus minus 2 and array of I, that is minus 2, which is maximum, that is comparison between 4 and minus 2. 4 obviously, so 4 will be stored over here. And what is the should I update the answer variable? 6 and 4? No updation is required. So moving on forward, next element, index number 4. And now for this, what I need to do, maximum of sum of I minus 1, that is 4, plus current element is 5, and the current element is 5 itself. Comparison between 9 and 5. What is maximum? 9. So 9 will be stored over here, and compare 9 and answer variable. Answer variable will say 9. Now anything remaining, no other elements are remaining, hence the output comes out to be answer, and that is 9. Is it clear, this process, this algorithmic part? Is this clear or not? Yes or no? We need a proper understanding of this process, because from this process you will be able to understand cadence algorithm. Okay, if you have any doubt in this process, then do mention it right now. Okay, I don't want anyone to stay confused in the cadence algorithm. Just quickly write down yes or no in the chat box if this approach, this part was clear to everyone. Okay, so I got one answer from Milan. What about other people? Pratik, Arushi. Is it clear to everyone? Okay, Milan and Pratik says yes. So now let's try to convert this into algorithm. Okay, so the algorithm looks like this. Okay, so now let's start. Let's understand. This looks nice, huh? Is it looking good? Sir, can we connect with you after this classes are completed? Yes, you can connect me over LinkedIn as well. You can look for Jay Dalsania, and I'll be like replying you if you have any queries. You can ask me over there as well. Okay, you can find me on LinkedIn. Okay, so now let's write down the algorithm. So algorithm is what? First of all, I need some variables. So the first variable is what? The first variable is the sum variable. So I need a sum variable. I need the sum array. I need the sum array, and I need an answer variable. So first step is to get an answer variable. Answer variable will be storing minus infinite initially, and I need an array that goes by the name sum. Initially, it should be equivalent to it should have size equivalent to the input array, and all the elements should be having 0. The entire sum array should be initialized with 0. And after this, what else do we need? For the zeroth index, as I mentioned, initialization step can be considered. So for other part, sum of 0 will be equivalent to array of 0. Now for the rest of the indexes, I'll be iterating from I is equal to 0 to so for I is equal to 1 to I is lesser than n. Now what I'll be doing, I'll be simply copying these steps. Sum of I is equal to maximum of sum of I minus 1 plus array of 5 plus array of 5. This part. And what else? I After calculating sum of I need to compare that value with what? I need to compare that value with answer. So answer is what? Answer is maximum of answer and sum of I. And the last step is to print the value of the answer variable. Correct? So this is the entire algorithm. Now this algorithm, what is the time and space complexity? Let's observe over here. Order of 1, order of 1, order of 1. This will be taking order of n time. Anything else? This is constant. This is also constant. Nothing else. So the time complexity is constant. I mean, it is linear, not constant. Time complexity comes out to be order of n. What about the space complexity? Over here, constant. Over here, order of n, constant. Nothing else, right? So the space complexity comes out to be order of n over here. NFT. Yes. See, there are two NFTs then, this and other one as well. Which one is better one? What do you think? Is this one better or this one? This one. Which one is better? Write down in the inbox, one or two. Okay. Okay. So now this is my time and space complexity. So will this algorithm work? Yes, absolutely. This algorithm will work. Do you want me to see? Do you want me to code this part? Auction रख लो. Okay, ठीक है हम auction कर लेंगे. So Pratik says two. अब आप बताओ. Milan, what are you voting for? You are voting for two. This one. Algorithm. This part. I guess this is far better. No? Bluish one. Where is it? This one. It seems to be like 3D kind of. I guess. Okay. So now let's quickly code this approach. This is not actually the cadence algorithm, but the concept used over here, that is finding maximum like finding the maximum subarray sum banding at the ith index. That concept is used inside cadence algorithm. Okay, so let's quickly code this approach and let's see if this approach gets accepted or not. Okay, this is not the final cadence algorithm. You will be still optimizing it. Okay, so now here is the answer variable. So again, regarding the data type, we need to. Okay, so everyone says two. Okay. Okay, so regarding the data type, what will be the data type of our answer variable? Let's say I'm initializing it as a minus infinite. Answer variable, what will this answer variable store? It is possible it can store the sum of the entire array. So now again seeing what can be the sum of the entire array, 10 to the power 6 into 10 to the power 7, 12 plus 1, 13. It can be as large as 10 to the power 13. So int won't work. Int data type will not work. So let's keep it as long. And what else do we need? I need a sum array. So is it after this? Let's observe the algorithm. Okay, one by one. So initialization step. The first step, sum 0 is equal to array of 0. Let's initialize. See the process. See the way I'm coding. No. See, first of all, what was my approach? I was going through the problem statement, and then I thought of brute force, and then I optimized it, and then see the most important part, which I uh, suggest every student, is that have the habit of writing algorithm in this manner. First of all, note down the algorithm on your pen or on your copy, and then only then start coding. Okay, so if there are going to be any kind of mistakes, any logical or anything, or any part will be missed, you will be able to observe in the algorithm written in your notebook itself. And directly debugging the code is very much stressful and it is very much irritating. It was for me back then, but now I have the habit of doing the code in this manner. Okay, so I suggest you guys as well follow this process. Try it once, you will be seeing the benefits of it. So now iteration is required. I is equal to 1 to I is lesser than n, and I plus plus. And what is the step? Sum of I is equal to maximum of sum of I minus 1 plus array of I. Sum of I is equal to maximum of sum of I minus 1 plus array of I and array of I. Now I need to update the answer variable. Answer and sum of I. And at the end, just return the value of the answer variable. This is the entire code for the algorithm which we saw right now. Let's see, compilation error, no compilation error. Let's try to submit and see if it gets accepted. Time and space, both of them are linear, order of n. Okay, we got a wrong answer. Why is it so? Minus 1, minus 2, minus 3, minus 4. Okay, so see, over here we did a minor mistake. Are you guys able to observe the minor mistake which I did over here? Okay, code debugging skill. Debugging is also a kind of skill. Okay, are you guys able to observe that why I getting this wrong answer for this test case? I made a minor mistake in some initialization part. I made a mistake in this 3 lines. Okay, Let's see if you guys can figure out, if you guys can find the mistake which I did over here. This is the test case: -1, -2, -3, -4. Output is -2 according to my code, but it should be -1. What mistake did I make over here in these three lines? 42, 43, and 46. Anything, anyone. A small mistake is there. I'll explain the reason of this thing. See, the initialization part. Sum of 0 is equivalent to array of 0. I have initialized the sum of 0 as array of 0. Now, sum of 0, if let's say the first element is your output, just like in this test case, the first element itself can be concluded as a subarray and its sum is -1 and it is having the maximum sum, right? So over here you can observe in the output, the sum in the output, the we can observe that the correct output is the first element and the code is giving us -2. So answer variable should be initialized to, let's say, a maximum of any. Obviously anything is going to be greater than minus infinite, right? So it can be initialized as array of 0 instead of keeping it as minus infinite. Now it will work perfectly fine. Let's say do submit directly. And the problem has been successfully submitted. Okay, so we got replies. Sum is equal to answer, Dinesh, and some. Yes, exactly, Milan, you got it. Initializing long answer. No. Okay, my Milan got it right. Dinesh, you didn't got it. Kind of. Sum is equal to answer. Sum is an array. Cannot initialize or give an array as anything. Hi, Prabhu Shankar. Hi. Okay, so now I want to optimize it a little bit. Okay, so this is my time and space complexity. I need to optimize it a little bit. How can I do it? So where do you think the optimization can be applied? Can I optimize the time complexity? Can I optimize the space complexity? I can somehow optimize the space complexity. Time complexity, at least you need to iterate over the array at least once. No, this is not a quadratic time complexity or not anything exponential. At least a linear time complexity is expected from the approach. So time complexity, no reduction. Space complexity, definitely I'll be able to reduce the space complexity. Can you explain that error thing once more? Yes, Arushi. See, the error, see, initialization is answer has been initialized as minus infinite. And what I did, sum of 0 was equivalent to array of 0. That's perfectly fine. Initializing the zeroth index of some array as array of 0. But what if in this case, just like the example or the test case for which our answer was wrong, so in this kind of test case, your sum array will look like this: -1, and let's say something something. Okay, I'm not calculating the entire array. So basically the answer is this subarray. The answer contains only a subarray containing -1. So basically, whatever is the value stored at the zeroth index was not at all compared with your answer variable. It was not compared with your answer variable. So what I did, I initialized the answer as array of 0 because answer was initialized as minus infinite and anything is going to be lesser than minus infinite. So I have compared answer with array of 0 or sum of 0, or you can add this part as well, simplifying it to the ground level. Okay, see, for the zeroth index we were not comparing it with the answer variable. That is the reason we were getting wrong answer, because the for loop starts from index 1 and ends at the last element. So for zeroth index we were not comparing it with answer variable. Now if the comparison is done, then each and every element is being compared. Okay, okay, got it. Hi Gaurav Kumar, hi. Yes, Pratik says since we only need the previous sum, we don't need an array. Exactly, Pratik. That is what the cadence algorithm is. Okay, so now let's understand what Pratik is trying to say. Okay, let's see. See, as I mentioned, time complexity, no reduction can be done. Space complexity definitely can be reduced. How? Let's see. See, if you observe over here, no, let me point out. This is the sum array, which is occupying order of n space. So, do you see the use case of any other element of your sum array? Let's say, while calculating the answer for this array, let's say at some point this was the condition, and now I wanted to find the maximum subarray sum ending at the index number 4. So sum of 4 will be equivalent to what? It will be equivalent to maximum of sum of I minus 1, that is 4. 4 plus array element, that is 5, and the array element, maximum of this two. So do you see that these elements are being used anywhere for calculating the last sum value? Do you see these elements are being utilized anywhere else? Do you see the use case of these elements? No, I cannot see. So what if I somehow keep the track of the last sum of I every time? What if I keep the track of this sum of I somewhere in some variable? Then I can get rid of the sum array itself. I can get rid of the sum array itself. So that is how I'll be optimizing the algorithm. Is it clear? Is it making sense? Is this making sense? Yes or no? Or do you want me to explain it again? Okay, clear to Milan. What about other else? Okay, clear to Arushi. What about Pratik? Pratik already got the idea. Milan also clear. Okay. So I don't think I need to explain it again. So let's reflect a few of the changes in this algorithm. So now completely eliminating the sum variable. I mean, completely eliminating the sum array. So instead of the sum array, I will eliminate it as an array and keep it as a sum. The sum will be equivalent to what? Sum will be equivalent to 0 initially. Let's say. Let me make it clear. Let me clean this. Okay. Sum will be equivalent to 0 initially. Now sum of 0 is equal to array of 0. This step is not required. So sum of 0 is equivalent to 0. Now answer will be compared. Okay. Answer will be what? Yet answer will be maximum of answer and array of 0. This is I'm going to do it for sure. Now over here, this loop starts from index number 1. So what I can do, if this loop is starting from index number 1, your sum will be equivalent to array of 0. Why array of 0? Because every time I need sum of I minus 1, and for the index number 1 I need sum of 0, and we know what is sum of 0, it is array of 0. So some variable is capable of storing the value of sum of I minus 1. Okay, so initially some variable will be equivalent to 0, array of 0, because my for loop is starting from index number 1, and answer has been updated, or you can keep the initialization part of answer to array of 0 over here itself. Okay, so this part can be eliminated as well. Now it looks more clear. Now sum of I has been removed. So sum of I is not an array, it is a variable. So remove it. Is equal to maximum of what? It is maximum of sum of array of I plus array of I. And over here, eliminate this. This is optimization of our algorithm. Space has been optimized to constant order of 1. Wasn't it very simple? Now, do you guys see that cadence algorithm is very easy to understand? Yes or no? Is this clear to everyone? A quick response from everyone if this was clear. So let's reflect these changes in our algorithm or the code which we wrote previously, right? So let's reflect these changes. So long sum is now not an array, it is a variable. Now sum of 0 is equal to array of 0. This is not required. So sum of 0 is equal to array of 0 will be initialized over here. And answer will be initialized as array of 0. So now answer is equal to math.max of. This step is not required. Now sum of I minus 1 will be now sum, and this sum will be equivalent to sum variable itself, and this, and let's try to compile and run. Yes, some arrays was never needed. It's exactly, Arushi. See, this works completely fine now also, and now let's try to submit it again. And the problem has been successfully submitted, right? See, this is order of one, space complexity, time complexity remains as it is, time complexity is still linear, and this is actually the cadence algorithm. So if I want to give you a key point about cadence algorithm, that is, you should remember that how to find maximum subarray sum ending at the ith index. Maximum subarray sum ending at the ith index. See, if you remember this point for cadence algorithm, never in future you will be able to forget cadence algorithm. Okay, you will not forget it. Alright. Okay, so this is our cadence algorithm. Any doubt till now? Yes or no? Anything? Anyone? Any doubt? So we have completed two of the questions. Now I'll be having a chit chat with everyone. Like, let's have some of the discussion. Okay. So do you have any kind of doubts or any questions you would like to ask me? After this, will be I'll be sharing the link of the homework question, and then the session will be ending. So till then, we have ample amount of time to discuss your problems, and whatever solution I feel will be right for you, I'll be sharing it with you. Last session today? Yes, yes, Milan. This is last session. CodeCamp 21, day 21 is the last day, and this is day 21. Yes, the series ends. The playlist and the recordings will be available. Obviously, you can look down the video recordings. It will be available. Okay. This camp helped me practice DSA daily. Yes, I was able to see many of you were consistently attending this session. And consistency is the key to master DSA. Basically, it's not like if you focus on solving n number of questions and you expect that I'll be good at DSA after a few days. That's not the case. Consistency leads to a good problem solver. Yeah, I used to watch videos by now. That too useless. Okay. Yes, Milan, that's exactly. So I see anything regarding any of the part of your, let's say, DSA journey or anything. So Milan says, yeah, I used to watch videos by now. That too useless. Sir made me do good utilization. Okay, you're welcome, Milan. Okay, so let me share the last question, and then after that we'll be ending the session. So the last question is very important from interview point of view. Okay, so the last question is very important from interview point of view. I'll be explaining the question. The problem statement is pretty short enough, very much self-justifying problem statement. So the name of the question is median of two sorted arrays of different size. There is one more variation. There is now one more version of this question. I would also recommend you guys to solve that question. That is median of two sorted arrays of similar sizes. Okay, and the other is median of two sorted arrays of different sizes. This is a difficult version of the uh, earlier one which I mentioned. Okay, median of two sorted arrays of similar sizes. Okay, so try to solve both the questions. First of all, solve that question, and then you can jump down to this question. You'll get a better understanding why these two questions are different. Okay, so given two sorted arrays, array one and array two of size m and n respectively, find the median of two sorted arrays. We need to find median. Okay, so after let's say uh, combining both the arrays, arrays 1 and array 2, you will be getting a completely different array that will also be in sorted manner. And in that sorted array, try to find the median. So if for the median, I don't need to explain it again and again. I guess you already know what is a median. For odd, the median is the middle element, and for even, you need to add the mid, that is n by 2 and n by 2 plus 1th element. Yes, length plus 1, length 2 divided by, and you apply the logic to find. We have seen the kth element of two sorted arrays. Okay, something can be done. Okay. So we have seen the kth element of two sorted arrays. Yes, kth element of two sorted arrays, median of two sorted arrays, median of two sorted arrays with different sizes. Can we apply that logic to find for k is equal to length plus 1, length plus 2 divided by 2? Okay. So no, actually that thing won't work directly. Okay, we need some modification. So I hope this question was clear. Let's see example number 2 as well. 4 6 1 2 3 5, combine both of them, so we'll be getting 1 2 3 4 5 6, and that array will be 1 2 3 4 5 and 6. So what will be the median of it? It will be median of 3 plus 4 divided by 2, 7 divided by 2 will be equivalent to 3.5. And the answer needs to be, if the answer is in double, then you should print decimal values as well. If it is integer values, then print the integer value. So basically, if I give you an idea on how to solve this question, first of approach is to merge both the arrays, array 1, array 2. If you know merge sort, you know how to merge two sorted arrays, and then you can find the mid element. And if this is not the case, what else you can do? You can use binary search over there. Okay, you can use binary search. Try to think how binary search can be used. That is the beauty of binary search in problem solving. It can be implemented at many places, but it's very difficult to see that how and where and in what manner can you utilize binary search algorithm. Okay, so I'm leaving that part on all of you. I want you guys to brainstorm a little bit, although this has been we have been in touch from 21 days and consistently practicing the DSA questions. So I want this question for you guys, like you guys practice this question and try to solve it. Okay, I have mentioned the other important questions as well. Median of two sorted arrays of similar sizes is the easier version of it, but not that much easy. and median of two sorted arrays of different sizes is the other version. Part 1, part 2. Is it clear? Okay. So that was it for today's session. I hope you really enjoyed this session. If you really like this video, then do like the video and share it with your friends as well, right? And do share the video with your friends if they are looking for the same content. And do not forget to subscribe to this channel. And about the Geek Olympics, okay? So explore that page. I've shared the link as well. It will be beneficial. Just like, see, if you are successful in maintaining consistency for 21 days, why not one more month? It is going to be beneficial to you, no? So try to maintain consistency in this kind of things. Okay, that will be fun as well. It will be a fun and interesting way, and you will not get bored in between as well. Okay, I hope everything was clear, and best of luck for the upcoming future. So this was the last day of our code camp. Thank you everyone. Thank you for joining this session, and have a good day and good night. Bye bye.